See. Okay. We're starting here on page 3. This is the first computing that we've done of sampling distributions, okay? So we did notes on our sampling distributions last week, or Friday we had done that lab, okay? So we had talked about this. And remember that we had the center was located right there where the true P is. So for us, the M&M's company said 20% blue. So that's where all the P hats should be centered around, is that 20% blue, okay? And then all the P hats should be centered. And then they had a different standard deviation. So the standard deviation, that average distance away for all of the P hats from that center, was computed with this formula. And so we're going to be using some of that same stuff today as we go on to our work that we're doing here on starting on page 3, okay? So, in fact, that's what it has first. This is going to be where all of our P hats will be centered. So, let's kind of do some things here. This is saying the average of all, and what's a P hat there? The average of all. What does a P hat stand for? It's a sample proportion. So a P hat, remember, every single one of you had your own P hat from the M&Ms. Okay? So the average of all P hats, all sample proportions, equals, and what's a plain old P? The whole population proportion, yes. So it equals what the whole population proportion is. Okay? All right. So I'm pointing out what all these letters stand for because it is important that you understand what each one of those little letters or symbols mean and stand for. Okay? It's very important. Okay, so then this next thing, we know what is that symbol. Good. Standard deviation of all P hats. And so, same thing. So that means the average distance that all of the P hats will be away from the mean. Okay? So notice we have P. So we have, again, that population P times 1 minus P. And then, what does N stand for? N is the sample size. So on Friday, you guys had 50 M&Ms in your sample. So you guys all had the N value of 50. Okay, so N is sample size. Now, this other thing right here looks really, really confusing, but it's basically your z-score. Remember, for our past z-scores, we have done our little x minus the mean over the standard deviation. So that is what we did if we had a population numbers. But here, look, we have proportions. We have a sampling distribution. So instead of being x minus the mean over the standard deviation, it's p hat minus the p over the standard deviation of p hats. Now we would just say the same thing, p hat minus the p over the standard deviation of p hats. Okay, not as fun. That's right. Okay. All right, so here we go. Let's go ahead and then start practicing these. Here we go. Number 1. An opinion poll asks a simple random sample, that's what your SRS is, of 1,785 adults, whether they attended church or synagogue during the past week. Suppose that 60% of the adult population did not attend. What's the probability that the sample proportion of those who did not attend last week is at least 58%? Okay, so we're going to write down information we're given first. So the first number we come to is 1785, and that is your sample size. Okay. Then suppose that 60% of the population So what symbol will represent 0.6? No p hat. Population is true p. Okay? All right. Now, what is the probability that the sample proportion, that's p hat, who did not attend is at least 58%? So that means the p hat I'm going to be referencing is the 0.58. Okay. So that's what you write down first. That's the information you're given. Now, let's write down the stuff that we need to write down for our normal model. Okay, so where is the center of the normal model? The mean of all the p hats will be what value? Nope. The center of all the p hats is going to be the population proportion. Okay, so that mean of the p hats will always be the p that they tell you, the population p that they tell you. Okay? And then the other thing that we write down is the standard deviation of the p hats, and that is this formula, square root of p times 1 minus p over n. Okay? So you want me to write the formula down there so you see where we get it from? P times 1 minus p over n, that's where this information is about to come from. So now let's fill in those numbers. Okay? So p is the value, what? 0.6. And what's the number what's 1 minus 0.6? That's the other part, 0.4. Okay? Over n. Over 1785. Okay? So if you put that into your calculator, and so let's just make sure you know how that's going to look in your calculator. Okay? I don't know. So second, so there's that. So I got 0.6 times 0.4. And because of order of operations, I can just type that all in like that, divided by 1785. So as long as it's all underneath the radical, I'm in good shape. 0.6 times 0.4 divided by 1785, and that's my number. And what we're going to start consistently doing is rounding to 2 significant digits. Rounding to 2 significant digits. So 0.01, and then tell me what should happen to that second 1. It goes to a 2 because the 5 behind it makes it round up to a 2. So 0.012. So 2 significant digits. Okay, significant, I mean wherever 2 numbers come about, like here's another one, 0.000203. I want 2 numbers in there. Actually, I mean, I think this would technically go just to there, but just do it until I get 2 digits, not just zeros, 2 numbers other than your 0, okay? That's what I think is going to be our good practice of making sure we have enough lettering, enough numbers. No, we're not finished yet. All we've done now is just laid the foundation for doing this problem. So that is the way every single problem will start. That'll be just a standard menu that you're going to put over there on your left-hand side, okay? N, P, P hat, draw your lines, mean of P hats, standard deviation of P hats, every problem, okay? All right, so now it says, so I want you to envision what we're doing is we're talking about a sample proportion. So we're talking about, a normal model that is centered around 0.6, and it has a whole lot of these little p hats in there. Why are all these p hats in different places? What makes us all have all these different p hats? It's called sampling variability. Because of sampling variability, you got different data than me. Sampling variability happens because you got different data than me. Okay, I don't think I've sang that one to you, but that's part of the Star Spangled Banner. We'll do that later, but sampling variability is happening because you get different data than me. All right, so this question says, what's the probability that you find, it wants to know you find this little p hat right here, which is 0.58. It wants to know what's the probability you have at least that p hat right there. So what's shaded if it's at least that little p hat right there? Nope, at least is going to be that much or more. If you need at least 20 bucks to go to the mall with, you need that much or more. So the question is asking, where is that point? I need that 0.58 and shade the area to the right. So what do I need to do here at this 0.58 spot? I need to get a z-score, and the z-score comes from, let's do that up here, z is p hat minus the p over the standard deviation of p hats. Sorry, just got to throw that in there. It is not as smooth, but it works. Okay. All right, so let's have you compute that. What is our p hat? I'm just pulling all of these numbers from all the work we did over there on the side. P hat minus the true p over that standard deviation of p hats. Okay, now I computed that, and that ends up being negative 1.67. Negative 1.67. Okay? So that's where that z-score is. That z-score is 1.67 standard deviations below the mean. So how do I get this shaded area to the right? Good. So I'm going to norm CDF. And how do I put it into that norm CDF? Good. It's the z-score. Make sure you are putting in the z-score, negative 1.67, up to positive 99. Okay, and I will tell you when you do that, you get 0.9525. Okay. All right, so how are we doing so far? Because I'm about to tell you one last thing that you need to know to do a problem, and then we'll just practice this a few more times. Okay? All right, so the last thing that I want to happen is for you to use some correct notation in your answer. So I'm going to teach that to you, and let's put this in another color so it'll stand out. So here's how we will write our answer. It's basically like stating a sentence, but with letters instead. So probability that p hat is greater than or equal to 0.58 is 95.25%. Okay, so write that down and we'll talk about it. Yep, this is something that I'm going to be checking for whenever we do quizzes and tests. Yes, we do have to. So I want to see the proper writing. So let me go through, once you have that written down, let me tell you again what that means. This first capital P, this means probability. So the probability that, and this p hat is, you get a sample p hat, and since it said at least, that's greater than or equal to 0.58. See, so that represents all of this shaded area. A p hat at 0.58 or more is that what you figured out, 95.25%. Sure. What if you had less than, then of course you would put a different symbol right here. Okay. This number is always, this p hat that you're trying to figure out. Okay, that p hat that you got. All right, so that's one finished problem. Let's kind of start doing the next one. We've got 4 total to do today, and they're pretty much the same thing over and over again. So here we go. Number 2, a quality engineer selects a simple random sample of 300 switches from a large shipment. Unknown to the engineer, 3% of the switches are defective. What is the probability that the engineer will find more than 5% that are defective? All right. So let's write down the menu of items I need in P hat, and then I want the mean of P hats and the standard deviation of P hats, okay? So that's what I want on every single problem to start with, okay? So let's see if you can't fill those in. Try that. Yeah, so first of all, is the population P 0.03 or 0.05? Which one's the sample and which one's the population? No. Unknown to the engineer, 3% of the switches are defective. So this is basically saying the fact of the matter is, so that is what's happening in the population. So that's kind of one of those things that you got to figure out. What's happening in the population and which one's the sample. Correct. So 3% is in fact what the population exists of, 3% defective. But what's the probability that he gets a sample that shows 5%, more than 5% defective? Okay. So what will be our mean of, where will our P hats all be centered around? 0.03. Okay. So the center will be that 0.03. What will the standard deviation come from?
Oh, wait, no.
0.03. What's 1 minus 0.03? 0.97 over 300. Okay? And if you need to go to 2 digits, let's take a look at what that looks like when we do that here. Square root of 0.03 times 0.97 divided by 300. And there is my, so 0.00984. So what's my 2 digits? No, 0.0098. I need 2 significant digits. 0.01 isn't 2 significant digits. 0.0098 is 2 significant digits, okay? So that's also kind of one of the things we're learning here is what is 2 significant digits. All right. So let's draw a picture of what this question's saying. Why do we get all these different P hats? Because of what? Yep, because of sampling variability. Sampling variability, sampling variability happens because you got different data than me. All right. So what's this problem want to know about? Yeah, how many? What's the probability that you find which samples? Which samples is it wondering what the probability of you finding it is? It wants to know more than 5%. So, well, where I don't know how far this is up, but here's a P hat. This P hat is 0.05, and it wants to know the probability of finding a sample here or what? more. Okay? All right, do you see that? So it wants to know what's the probability, what proportion of samples are 5% or more? All right, so what comes next? Z-score, very good. Okay, my Z-score is going to be?
P hat minus P.
Good.
Standard.
Very good. P hat minus the P over the standard deviation of P hats. Okay? And once you get that, how do you find that? Now that's just the Z-score. How do you find the area? Good. Which way do I norm CDF? 2.04 to 99. 0.0207. Okay, and then final step is the fancy way I want you to write the answer. So how's the fancy way I want you to write the answer?
What's the probability of parentheses P hat?
Actually, it does just say greater than in the problem. Okay. And what's that equal? 2.07%. So, you know what? Here, this is like a for real life situation of how this could happen. This is important. Say you are a person who you're a manufacturing company. You own a manufacturing company. And you know that in fact you are sending a shipment to this person that has only 3% defective. Okay? But so they're going to take samples. They want to test them before they take them or not. You know, and we did this. Hey, let's say the Lay's potato chips. Remember? Say you're the farmer with the potatoes. You go to the Lay's potato chip place and they want to see that only 3% of the potatoes are, or only 3% of your potatoes are defective. They will reject your truck if more than 5% are defective. So the question is, what's the probability that you're going to get rejected even though in fact your truck is acceptable? Because if they got one of these samples up here, you're going to get rejected. And so there's only a 2.07% chance, so luckily it's a small chance, that they would get one of these samples up here that would reject your truck, even though in fact your truck is a good truck without too many defectives. Okay, so now what I want you to do is the next two problems. Okay, so these next two problems are going to be what you're going to do, and I'll walk around and help you and check those with you, so work on those now. Let's have a discussion about this problem because the question that it asks is actually a little different than some of the other ones. Okay, so let's take a look here. So essentially this is saying, so suppose that, say, the entire United States or even Texas or whatever, so some bigger population has 7% of people indeed have hepatitis. Okay, so that's reality. Well, but we get a sample and we're just testing Alito. So when we tested Alito, we got a sample that had only 3% that had hepatitis. So, is that okay? I mean, is that just because it's sampling variability? You got different data than me? Or is it way far away? So I want to know how far away is this, because if it's really far away, then I'm going to start thinking Alito doesn't have 7% defective. They have got actually something less. So I get my Z-score, to see how 0.03 compares to that 0.07. And when I did that, I got a Z-score that's negative 2.02. What do you have to say about a Z-score of negative 2.22? Would it be considered an outlier? Okay, so, hey, that's the key right there. Listen up, guys. It is the key that the sample I got was an outlier. So since the sample I got was an outlier, that shouldn't happen. Outliers should not happen if this 0.07 is really true. So that makes me start wondering, do you think 0.07 is really true? Okay, that's what it makes me wonder. Because if 0.07 is really true, I should not have gotten an outlier because they are extremely rare. So I then have a suspicion, and this kind of is going to lead us into an upcoming unit. So I suspect that 7% is not true. So that's what is going on here. I'm suspecting that 7% is not true. So let's go ahead. I had told you, go ahead and find the probability that you get a p hat less than 0.03. And that ended up being, when I calculated it, I think was it 1.32%? Okay. All right. Okay, very good. So that problem was a little strange because it asked some different questions, but number 4 should be more straightforward. So go ahead and follow that through on number 3, 1.32%. Okay, so let's go ahead and check that last one. Okay, so we got p hat, which is your 0.31, minus the p over the standard deviation of p hats, and that ends up being a z-score of 1.15. Is that unusual? Would you be surprised if you got that p hat, or is that because of sampling variability? It is just because of sampling variability, because you got something different to me. So it said at least that amount. So I will be norm CDFing from 1.15 up to 99, and that's 12.5%. So let's do the correct notation for the last part. The probability, that's your capital P, parentheses, that I get a p hat that is at least 0.31 is 12.5%. So that is the final answer, and I want to see that notation. I'm teaching you how to do that as well. Okay? All right, so tomorrow you guys will just practice those